a lot of math, obviously, and visualization. That is plotting, but also we have some other visualization prepared for you. Everything will be in .NET, so in particular the language will be C#, and we will be using, as an IDE, we will be using the Visual Studio. Let's start our presentation here and introduce the speaker. So my name is Daniel. I have been working in science for 10 years as a researcher in theoretical chemistry. I've worked at different universities, and I have been focusing on numerical algorithms to solve the scientific problems at hand. And recently I joined the Ilnumerics company, and I'm in charge of customer relationships. So whenever you would like to get in touch with us, most likely it will be me who will be in touch with you. Joining me is Heimo. Heimo is the head of development, and he has all the answers to all your questions. So in case that I can't answer it, he will be sure to answer everything. He's a real good expert in C# and has also 10 years of experience in software architecture. Altogether, that makes a great background to develop a library like we will be presenting today. Ilnumerics is a company. We're based out of Berlin, Germany. Here's a little map with a pin where Berlin is. That's where we sit right now. What we do is we develop software components. So this is a library. This is not a standalone application. It's meant for developers who want to develop a software application. And we give you some components, for example, mathematical functions, and we will have a look at what we offer there and how you can use them, and also some visualization functions. The visualization is obviously very important, not only in the context of scientific plotting, but also in industrial applications. We will have some pictures there too. For example, computer-aided design, so the CAD is an interesting topic here. And we also have some developer tools that we would like to introduce. These developer tools, they will help you understand, help you during the development time, reduce your debugging time, make it clearer for you where the problems are, and overall just help you to develop your software application quicker and better. Now, here let's say something that we consider the Ilnumerics Pyramid. So we have 4 layers, and on the top layer, the bottom layer will be the hardware. Here we have the hardware, and you know all that, the multi-core CPU and GPU and SIMD and a lot of other resources that are available there. These are typically offered by these big companies, Intel, AMD, NVIDIA, and you have a number of functionality there that in principle you can use, but usually for a regular developer it's not so easy to access them. So this next layer will be the .NET layer. In particular for us would be C#. So that's a managed framework, allows you to access this hardware very easily, allows you to manage the resources. It gives you a lot of functionality to access the hardware that we just talked about. And this, obviously, we all know is managed by Microsoft. Now, the third layer will be the Ilnumerics layer. And what we do is we offer these computing and visualization routines, development tools, toolboxes. So we specify now on the numerical part. And the topmost layer will be the developer, where you can implement very efficient, very robust algorithms that go quick and are very reliable. The implementation is really simple. You can do some quick prototyping. You can do a number of things, and we want to introduce what you can do today. And if you like it, and if you would like to work with us, this is where your logo goes, the top of the pyramid. So this was basically the introduction. Here I have the outline of what we will be looking at. First we look at the computing, mathematics. After every point that I have here on the slide, I will give you the opportunity to ask some questions to whatever we talked about. at that moment. So we start with computing, then we will explain how we make sure that we are very performant, and then we'll look at the visualization, and at the end I will just give you the summary again, the overview of what we have heard, what we have learned, and what might be interesting for you. Okay, let's get to it. So Ilnumerics, we have a slogan, a tagline, like every company nowadays, and our tagline is "You do the math, we do the rest." So we'll start with looking at the math. The math basically is centered around our computing engine. The computing engine consists of a number of things, and one is the comprehensive library that we offer. Now, comprehensive is easy to say, and I created a little slide for you to hopefully get an overview of what we're offering here. So there are a number of different things on this slide. Let me try to walk you through this. We start here with the linear algebra. So this is your typical matrix vector manipulation. This might be multiplication. This might be solving of a set of linear equations. You might want to find the eigenvectors or eigenvalues of a function. You might want to calculate a sign of a matrix. There's a number of different routines that are all subsumed under the term linear algebra, and that is something that we offer. We have this little icon here, so it looks a bit like a matrix. I hope that's clear. Then next up here is the optimization. We have a number of routines that allow you to optimize a function. So if you want to find the minimum or the maximum, you want to find the least squares or something like this, we have functionality for you. You need to provide us, or you need to implement, obviously, the cost function, as we call it, and then our algorithms will find the minimum or the maximum, whatever you are interested in. We have Newton type optimizers. We have the Liebenberg-Marquardt algorithm for the least square fit. We offer a number of different functionalities here. The FFT, the fast Fourier transform, is something that a lot of people are interested in, image processing, in signal processing. So that is something that we offer as well. Then we have some statistical methods. So if you have data where you want to do some statistical analysis, want to find out standard deviations or R, or your typical statistical methods are implemented as well. We also offer machine learning part. So the machine learning it goes hand in hand with big data. So if you have big data, you want to analyze that with machine learning, we have some tools for you that will help you do that. Those are, let's say, the core mathematical functionality of our library, of the computing library. And then there's, let's call it, two extra functionalities. So one is HDF5 interface. That's the hierarchical data format. That's a format, an international standard of saving data, hierarchical data. We can read and write. So if you have some legacy data or you want to interface with a certain other application or whatever you have, there's data available in that format. You can read it in and you can manipulate it with Ilnumerics. The other interface that we have, actually it goes through the HDF5 interface, but it's an interface with Excel. So basically you can use our library to do some plotting or also some calculation, but your interface is Excel. So you have your Excel sheet and you enter your data, and then in the background our engine does all the computing for you. So this is kind of an overview of the library of the mathematical tools that we offer you here. The second part that we would like to stress here, and I know this comes up all the time, well, how simple is that? We really spent a lot of effort to make it very simple and very clear how the syntax is and how you use everything. We have extended documentation online, and we have two what we call cheat sheets And I would like to show them to you. Those are PDFs. Let me see. So here is, for example, a PDF that gives you a number of different functions that are all centered around our array class. The array class is the core of our library, and it holds as many dimensions as you want. So it's not only vector or matrix, but you can go to 3, 4, 5, as many dimensions as you want. Okay. There's a number of creations. You can fill them with zeros or with ones if you want. Okay. You can fill them with random numbers, the identity, a diagonal matrix, linearly spaced, logarithmically spaced, just an empty array. Then we have a number of properties where you can check, for example, is this a scalar, is it a matrix, is it a vector, is it a column vector or a row vector, is it complex? And then, of course, we have a number of methods, right? We can reshape them, we can shift them, we can get values, we can set values, things like this, obviously. And then here's all the slicing and dicing of a matrix where you can say, okay, I want to have the, let's say, the 3rd, the 5th, and the 7th element, or I want the elements 7 through 10. All these different ways to access an array. I'm sure you all have worked with arrays. I mean, that is not a new thing, but our array class is particularly well performant. Let's say we are really it's really very important for us to make sure that your algorithms work very quickly, and this is why we implemented this array class. The other sheet that I wanted to show you is a comparison between MATLAB and Ilnumerics. So MATLAB, I'm sure a lot of people have heard of it, is a prototyping standalone software application where you can do a number of different routines, and it is widely used in science. Also, I have vast experience with it. And here, this is a sheet where you can see, okay, let's say I know this routine in MATLAB, how do I use that in Ilnumerics? And here you see it's basically identical, right? If I want to know, let's say, the size of a matrix, how do I get the size, right? Then here are a number of operators, right? We can have like binary, so element-wise operators if you want. And then there's really matrix multiplications that are available, trigonometric functions, obviously, that are available, rounding, for example. Here's the linear algebra. You know, we have these LU and QR decompositions. The singular value decomposition, obviously, is in there. And all the fast Fourier transforms are also in there. So hope this gives you already kind of a sense for how Ilnumerics works. It's very much similar to MATLAB, to, let's say, standard scientific notations. So that is the syntax. Now, very important is the Visual Studio integration. Because whenever you work with .NET, obviously you're working with Visual Studio. And so we made sure that our library integrates very well with Visual Studio, and we'd like to show this to you. So here, this is the Visual Studio, and let me create a new project here. Let's do a Windows Forms application. And here it loads and everything is in there. I guess this looks very familiar to you. Here on the left hand side we have the toolbox, and you see already we have a point here, Ilnumerics, and we have an IL panel that I can drag and drop into this form. And now I just fix it with the docking option here, and here we go. This is the form. Okay. So you see already the integration of Ilnumerics. You also see here's a reference to Ilnumerics, obviously, because it's an extension. And I would like to add now a new item, and I would like to add a plotting form. Again, this is an Ilnumerics form that is integrated here. Now I add this, and it gives me already a number of functions that are defined for me. Let me take away here the comments. You see, it's not too much. It's a few lines, and it gives you already some pre-configured functions. Now let me just add this here real quick, and we are good to go. So you saw I basically didn't do anything yet, but we can compile it already, and we get a plot, and the plot is, well, looks like a circle. But if you go and rotate it, you see it's more like a helix. You can rotate, you can zoom, right? You can pan, your regular things. Now this is very nice. It was very easy, very quick. Didn't have to do a whole lot, and already I have a plot, and I could change now the definition of this spiral if I would like to. Let's go into this function here. This is where the spiral is defined. So the matrix POS holds the x, y, and z coordinates. The x coordinate is a sine of A, the y coordinate is a cosine of A, and z coordinate is just A, and A is just linearly spaced numbers from 0 to pi. Okay? Now this is fairly easy. Now imagine for a moment that let's go in debug mode, and we're not sure whether we implemented everything correctly, and we would like to debug it a little bit. And for example, we would like to see the values in this matrix pause. So what we developed is what we call the Ilnumerics array visualizer, and this is where it comes in. So right now we are at this line. This line hasn't been executed yet, so pause doesn't exist. So let's go one line further, and you see already now we see it does exist, and it's loaded with all zeros. Now this by itself is nothing new, and you can have that already in Visual Studio. You look here at the bottom, there's different ways that you can also visualize really what you have in this matrix. Now there's a dot right here. I'm not sure if you see that. It's a dot at 0, 0, 0. You can also have the scattered. It's the same thing. Here we have lines, right? This is, I think, interesting for us. So each row of the matrix pause has some values. Right now, all these values are 0. Let me go back to text mode. You see they're all 0, okay, of every line. Now, let's go back in the code here and go further one step, one extra line. What will happen is we will load the first row of pause with sine A. Let's see what happens. Nice, right? We see that row 0, which is the first row, now has a sine curve, okay? Whereas the other rows have no curves, okay? I go one extra line, and now the second line also, this time it has a cosine, okay? And then I go one line further, and this is now the linear. So basically, the way you want to read it now, let's say here the 50th element, you will have X, here is the blue, Y is the red, and Z is the green. And all together, it will give you, all together it will give you this helix. Okay? Now, I think you got an understanding of what the array visualizer is. How does it help you? Imagine for a second that we made a mistake here and we didn't put sine but the log instead of sine. Okay? Now I'm going to stop debugging and I will do the same thing again. Okay? Now we'll start with all zeros and we can plot the lines, and then I go the next step to the next line, and I see already, oh, this is not a sine curve as it was supposed to be. It is just a log curve. So I know that in this very line there must be an error, and I can go and fix it. and then I can go step by step. And also, when you look at this, obviously this is not what you wanted, right? This is not the spiral that we saw at the beginning. So you can fix your bug really quickly with this, what we call the graphical debugger, and then you will get finally what you were interested in. Okay. This was, let's say, an easy example with from scratch, basically. I didn't do a lot of coding. This was all done already, and I introduced the Ilnumerics array visualizer. Now let's look at a different example here. I'm going to open a. I'm going to stop this. I have to open a new project that I implemented earlier, which is called particle in a 2D box. Now this is an example in quantum mechanics, and if you're interested, you can, let me show you, this is our website. You can go on our website, there's a blog. I'm going to go there to the blog. And here's a blog post. It's actually a series. We have 4 blog posts, Ilnumerics for Science. And if you're interested in that, you can even download the source code and read it, and everything is explained. It is a particle in box is a very famous example in quantum mechanics, and I quickly implemented to show something here. So what we're looking at here now is the computing part of this example. Consists basically of 4 functions. We have the calc data function, which is a wrapper around everything. We have the get grid function because it generates the grid, and then we have 2 functions, one for the wave function, one for the density. Now the physical reasoning behind it is not so important for you. This is what you get. Okay, we have a panel with 2 different plots. They're again 3D. If you see, they're not identical. This is the wave function, this is the density, so basically this here is the square of this. And then we have some parameters which are called eigenvectors in physical language here, and they decide what type of solution you're looking at. And you see how the density is always positive, obviously, because it's the square. This wave function can also be negative. Now, we have a mesh size here of 100. That means we have 100 by 100 points. So we're at 10,000 points right now. And let's increase that. Let's do that 500 by 500. And you see how quickly everything is done. You see that now the mesh is a lot denser. And 500 by 500, let me remind you, that's 250,000 points. Okay? So you see we really spend a lot of effort to make sure that everything is very, very efficient. So even 250,000 points, no problem, we can handle that. I would like to here change a bit the implementation just to show you that that's very quickly done. So here, this is the definition of the wave function. So of the left panel, I'm going to comment it, and I'm going to just do that. So that's basically x squared times a sine of the x vector, eigenvector times y. Just whatever, you know, I just tried to show you how all this changes here. And now I can have different parameters, and you see how you can also be interactive if you want, if you're interested in that. And then you get a nice, interesting curve like this. Okay, and again, obviously, 500 by 500 should also work. Okay. This is what we wanted to show you from the computing part right now. Let me go back to our presentation here. I showed you the Visual Studio integration, how it integrates with the IDE and the Visual Debugger that we offer. But we're not done, right? We have a roadmap. We are going to keep developing. We have a number of different things that we would like to include. That's real upgrades, but also some updates, just making things a bit easier, maybe a bit more efficient. Some maintenance in the rare event that we find a bug or one of our users finds it. We are very quick to fix everything and make sure that everything is really working very well. That is very important for us. So this brings us to the end of the computing part. If you have any questions about the computing part, this is a great time to ask.
We have a question from Juan. Which are the benefits of having these programs in terms of design and time?
Okay. So time, there's two times to consider. One is the development time and one is the execution time. Now, the execution time, what we hear from our customers is that they can't find any better library in .NET. So if you really have a lot of data and execution time is important for you, then I think we really have a good solution for you. The other question about time is the development time. So how long does it take you to actually develop an application that you would like to develop? And here we offer you a lot of functionality already, so that should really cut down your development time. It's not only that we offer the functionality, but we also offer it at a very high quality. Okay, so things really work. So you don't have to worry about it, and we maintain things. So I think those are the two time savings, execution time and development time. If that is interesting for you, if that is something that you care about, I think we have a good solution for you.
Okay, and we have another question about the pre-configured functions. They are asking if they have the possibility to build their own pre-configured functions.
Okay, I'm not 100% sure if I understand the question. So one thing is the functions that we offer, they are maintained by us, and you cannot change them. However, you can create your own functions, right? You can develop your own functions, and if you think that, let's say, our sign function is not implemented very well, you can just re-implement it. Yeah, I hope this answers the question. Of course, you can use a number of different functions and build your own application, right? I mean, we're a library, so obviously you can do these kind of things. Does that answer the question, or do you maybe have a follow-up question?
Yeah, Carlos, I think he didn't say anything else in the chat.
Okay.
So I think those are the questions we have from our part.
Okay, great. One thing that we get a lot of questions in this part is, I have a MATLAB code, I have a Python code, can I easily migrate my code into C#? The answer here is that, well, MATLAB and Python are more prototyping languages, whereas our language is really a production language, so it's robust and reliable. You can translate your MATLAB or Python code into C#. You have to tweak it a little bit. You have to do some changes, obviously, but typically it doesn't take so long. So that is something that people usually are interested in when we talk with them. Okay, let's go to the next part here, and this is the performance. I'm sorry, here, the performance. And we had the slogan, you do the math, we do the rest. Let's talk a little bit about the rest, and we give you kind of a peek just behind the scenes of how we do things. Okay, so first thing here, let me give you an example for execution time. This is an example for k-means clustering, so that's a machine learning problem. If you're interested, please check our blog for details. The numbers here on the left, that's not so important whether this is 20 or 25 or 15 or whatever. The the message we want to convey here is that we are at par, rather equal with native languages like Fortran or C++, and by far outperform, for example, MATLAB or Python. Okay. At the same time, Ilnumerics retains the convenience of MATLAB and Python, as I hope I was able to show, whereas if anybody has ever programmed in Fortran, and I actually had to, it's a pain. So Ilnumerics kind of gives you the best of both worlds, right? It's as convenient as these two and as efficient and fast as Fortran and C++. Let me show you a bit how we do that. So let's say we have now our example here. This is some timings on an AMD 6-core processor, and the problem at hand that we had was taking us 1,264 milliseconds. Now, obviously, that's not a lot of time, but it's just about to give you an idea of how much are we able to reduce the time. 1,264 milliseconds. That's the start. Okay, what do we do? The first thing we do is we do a cache optimization. And the problem is that arrays in C# are typically stored in row major. So that means that the elements are stored first the first row, after that the second row, and then the third row, and so on and so forth. So if you access these elements in this order, that is very efficient. However, if you want to access the column, then you always the processor has to jump from the first element, then to the, in this case, 11th element, and then to the 21st, and so on and so forth. So it's jumping, and that is not efficient. We were able to optimize that and really take care of this cache. And by doing so, we were able to reduce the 1,264 milliseconds all the way down to 245 milliseconds. So that's an 80% reduction of the time just by cache optimization. The next thing what we do is a parallelization. I'm sure you all know that modern CPUs have more than one core, so you have to somehow distribute your tasks to the different cores. They go from 2 all the way up to, I think, 12 cores by now. And when you do that, the parallelization, we go from 245 milliseconds down to 127 milliseconds. So it's almost another 50% that we cut, okay, just by parallelizing things. Now, we're not done yet with the parallelization. There's one more thing that we need to do here, and that is called memory management. This is a bit an expert thing, we'll still tell you here. So what you see here, the blue line, this one, the light blue line, is your processor time. The red one is the time the processor spends in garbage collection, and the purple line is what we call paged faults. Basically what that means is that the processor would like to do some work, would like to do a calculation, but it doesn't get the data. The processor is waiting for data, okay? And we address that with our memory management. Okay, so now remember the purple line is kind of up here, the red line is kind of up here. We would like to ideally have it all the way down here. And that's what we do, from 127 milliseconds down to 39 milliseconds, another 70%. And you see almost no page faults, almost no time in garbage collection, and we almost completely use our processor resources here. So we really managed to get down the time. It's not all. We do 3 extra things, very expert things here. That's loop unrolling, pointer arithmetic, bound check removal. Really for the experts, not everybody needs to understand everything here. We wanted to give you kind of a feeling of what's going on behind the scenes and how come that we are able to do these things. That was quick. That's the performance part. If you have any questions here, very welcome to ask.
They are asking here, Maria, for which areas does this works more? these benefits?
Okay. So it is important that you kind of use our array definition here. That is important, and you need this a certain way that you should write your function. If you define your own function, and you should make sure that the argument that you accept is an Ilnumerics array. And if you do that and implement your function correctly, then you should benefit from all of this and should be really able to process your data very quickly. This is something that you will see only if you have large data. So if your matrix or your data set is, let's say, 5 by 5, you will not see anything. Okay, but if you're looking at 100 by 100 or even larger data sets, then you will really see a difference in timing.
Okay, I think those are the questions we have from now.
Okay, great. We go to the, let's say, kind of the last chapter, and that's the visualization. Now, for the visualization, I don't have any slides, but I would like to go back to the Visual Studio and show you 2 other examples. You will also find these examples on our website if you're interested. You can download them with the source code and play with them. So one thing is really here, I would just like to show you something. Because we have seen so far, all we've seen were kind of plots of, let's say, kind of scientific data, and we just want to show you that's not all we can do. So this is a piece of maybe a machine. We just thought of it. It's not a real piece, but it's something that looks like the CAD, computer-aided design programs that some people use, and then you can obviously do the same thing here with this and do a lot of different things, zoom and all that. We have a kind of interesting use case on our website, the finite element analysis visualization here by Greg. He shows us these nice pictures. These are all pictures that you see right now. They are all done with Ilnumerics. That's not something that we have done. This is something that Greg has implemented. And if you're interested in this, here you see those are cracks. So they are interested in these pieces, and they want to understand how a crack propagates through their piece. And so this is something that they simulate and visualize. If you're interested, just check the use case here and on our website, and you will see that. Okay, so that was one thing I wanted to show you. The other visualization that I would like to show is an interactive visualization. So we've shown you now these plots, and we've shown you this, let's say, kind of CAD. And now we'll show you how these visualizations can become a graphical user interface. Oh, I'm still in the wrong. I'm sorry. Sorry, I opened the wrong one. Here we go. So this is now this is not very impressive by itself, the plot. But what you see already is this red dot. And when I hover over it, it gives me data if I want. It gives you X value, Y value, Z value. This is something that you can implement yourself. Okay? So for example, here I commented this out so far, but I add this. It gives me an interactivity that I can use, so that, for example, if I get this plot back here, and I go on one point here, so let's say this one, I'm going to do a left click now, okay? Yeah, left click, it says left click, and then I can do a right click, it gives you something else, and I can do also a middle click, Here we go, and it gives you a middle stick if you want. So basically, what this shows you is that that you can use any events, any mouse events, hovering over, left click, right click, double click, whatever you want, any mouse event you can use and then handle it and do something with it, right? You can really use it as a graphical user interface. So you can say, if I click on this mouse and on this point, then menu pops up here, right? And if I click on this one, it will pop up here. And if I click on this one, something totally different happens. And if I click on this one, maybe a YouTube video will be played. It's really a very nice feature to engage the users of your applications. And it gives you all the functionality of .NET. I mean, then you're not restricted to what Ilnumerics does, but it gives you all the functionality that you can find in the .NET community there. We thought this was really a nice feature for people to know. We're curious about what you and others will do with it, with this particular feature. This was basically already the visualization that I wanted to show you, because we had already some other visualizations. If you have any questions for the visualization, please shoot.
I have a question from one of our users, but it's more like that Anna wants to know which projects are you doing right now, and if you have any example or of a success case you want to share.
Okay. Yes, we have these use cases online. So this is, for example, I showed this already. It's Quest Integrity. This is a use case that I like in particular. Those are students, and they had this problem of detecting objects in a landscape. So that's for aerospace. I also thought that was an interesting one. We have a few more case studies here. Weather analysis, industry surface plots with a customer of ours, Zico, they are called. So they have these machines where they do an ultra precision polishing. Okay, so they have surfaces and they need to be super polished. Okay, and they use our library. They used to have MATLAB. Now they use our library to calculate the paths of how to polish it, and have then they have something that they call the Zico Studio. Okay, and this is Ilnumerics is integrated in there as the math engine and also the visualization engine. So there's a number. We have a number of customers worldwide. In Europe, obviously, a number also in the USA, in Asia. We have a number of customers. We can't put every customer on our website. Some customers don't tell us anything because it's a secret. But whenever it's possible, we put it online, and here's the case studies if you're interested in that.
Okay.
Maybe one question that we get a lot is yeah?
No, you go on, and then I'll ask you other questions that are more general, so you can.
Okay. Yes. A question we get a lot for visualization is, do you do real-time visualization? Okay, I have data and I collect it like constantly, and I want to visualize it constantly. So when we get this kind of question, the first thing is real-time. It's a clear definition of what real-time is, and Windows can't do real-time. Only embedded operating systems can do that. So with a clear definition, no, we cannot do real-time. However, some of our customers, they have a sampling rate of 100 Hertz, so that means 100 points per second. And they are able to show that without any problem. I mean, you don't see any delay on your screen then when you're interested in that. So real-time is something that we can't do in a strict definition, but to your eyes, you won't see a difference.
Hi, hey. Okay, now I'm gonna go for some general questions we have.
Yes, sure. Go ahead.
We would like to know for which sectors are you working now? What projects are you dealing with? Are you managing?
Okay. So, in fact, we have customers from really a lot of different industries. Um, we have a race car customer, for example. Okay, we have a big automotive as customer, for example, Porsche. You know, the big German company. They make these cars, Porsche. So they are customers of us. We just saw the Zico. They make these machines, these polishing machines. We really have a broad spectrum in terms of industries. But what is kind of similar to all of our customers is that they have a department, a dedicated IT department that develop a software that is important for the company in some sense. Okay, so for example, Zico, to their machines, to do the polishing machines, it's important to have a program that finds the right path. So that's a centerpiece for them, right? So the companies that we work with are very dispersed, but the departments are always, let's say, R&D departments that are really interested in high performance, crunching numbers, and nice visualization capabilities.
Oh, that sounds very interesting. So if you want to continue with the summary, and then we'll continue with the next questions.
Yeah, it's just one slide, and then we're done from my side. So if you're interested, I would encourage you to visit our website. You see here at the top. You can download our library. It's for free. You can use it 14 days. No strings attached. What we will do is we will ask you for your email address. We will send you a link where you can download it, and 2 weeks later we will send you an email telling you that your trial is about to expire. We will not call you. We will not send extra emails. We will not bug you unless you're interested. And if you're interested, then of course we love to talk with you. Just want to kind of summarize here. We have the computing engine with array class. That's kind of the center of it all. The linear algebra, FFT, and HDF5. We talked about that. The visualization is not only plotting, not only the scientific plotting, but also the graphics. That's why I put this picture here. And very important, the interactivity. We are a Visual Studio partner, and we are integrated. We integrated our library into Visual Studio with graphical debugger, IntelliSense, everything is there. And then we have a number of toolboxes, the optimizer, interpolation, statistical, machine learning, all that. And then we put it on the website, and so we also tell you these are our prices. Feel free to check it out, tell us if you're interested, and we're happy to hear your questions, your feedback, your concern, everything. Very open here.
Okay, perfect. Very good to know. If you have any slide of your contact, that would be great so the assistants can see it. A question that I have is like, which one is do you have a competition? Which one is, and what are your advantages in front of this competition?
Yes. Okay. I mean, I talked already about Python and MATLAB. Those are okay. Python is a language. You have a lot of different features there. So let's say it is kind of a competitor to the .NET family, if you want. We still believe that we do a lot better. We are a lot faster. We are talking right now. I'm sorry, I can't say the name. I would love to. It's a very, very big company, a global player, actually located in Germany, but we're talking with them in the US, and they are migrating from Python to our solution. They're extremely happy, And if you check our website in, let's say, 3 or 4 months, I'm sure you will find the use case from them on the website, and then you will know who I was talking about. But right now, I'm sorry, I can't say the name here. So Python and MATLAB. But those are more like prototyping languages. So they give you a lot of convenience, but they are not as robust, they are not as reliable, they are not as fast. So if you really want to do a production run, they might not be the best solution for you. There are some solutions also in C#, but they are not as extensive. They usually don't have computing and visualization. They are never as fast. That's what we hear from all our customers. When they're really concerned about the speed, then they will choose us. I'm not sure if you're going to believe me, but I can tell you that's what I hear from our customers. And we're happy to hear it from you as well if you try it out. And please let us know. Also, let us know if you're not faster.
Okay. Yeah, now I think we're curious to know which one is the one that is changing to the new. So we're gonna be like watching your
well,
web
like
page
I said,
to
I'm
see.
sorry. Yes, it's a global player from Germany. I can tell that, but yes, I'm sorry, I can't say that right now because
It's okay. It's okay. We have a good hint right now, and
okay.
our curiosity is gonna make us be like these 4 months, like watching out what is new with Ilnumerics. First of all, thank you, Daniel, for your presentation. It has been a very interesting presentation and demonstration you've made. Before I end the webinar, I would like to remind the assistants that you will all receive the recording of this webinar, so you can have it, review it, or share with your teams. Remember that for more information about Ilnumerics webinars or other IT webinars, you can go to technowebinars.com and review our agenda. I think we don't have any more questions, Daniel and Jaime. Thanks a lot for your participation.
Well, thanks a lot for having us. I appreciate the invitation here. I hope everybody got some information out of it, and we're looking forward to hearing from you and hear what your problems are, what your projects are, and what you're trying to achieve.
Okay, perfect. Thanks a lot, and see you. Goodbye.
Bye-bye.